Deep learning. You hear that term everywhere, right? It's one of the most powerful and, let's be honest, hyped technologies on the planet. But what is it, really? In this explainer, we're going to pull back the curtain and build an artificial brain from the ground up, starting with just a single, simple decision to see how these things actually learn. Okay, here's the game plan. First, we're going to get the big picture, see where deep learning fits in the whole AI family. Then, we'll build our own tiny decision maker, a single neuron. After that, we'll see how to connect them into a powerful network, figure out how that network actually learns, and finally, we'll connect it all back to the technology you're already using every single day. Alright, let's dive right in. Before we can really get our hands dirty building anything, you gotta know where it comes from. Understanding the family tree, the difference between AI, machine learning, and deep learning is absolutely the key to cutting through all the noise. And this is probably the best way to picture it. Think of it like those Russian nesting dolls. The biggest doll on the outside, the whole grand concept, is artificial intelligence. You pop that open, and inside you find machine learning, which is a specific way to do AI. And then you open that one, and you find the really powerful, specialized tool we're talking about today, deep learning. So let's start with that big outer doll, artificial intelligence. I mean, this is the original dream, right? The science fiction idea of building machines that can think, reason, and solve problems basically just like a person can. So how do we get there? Well, that's where machine learning comes in. And this is a total game changer. Instead of a programmer sitting down and writing millions of lines of code for every possible outcome, you just give the computer a whole lot of data and let it figure out the patterns for itself. It actually learns on its own. And that finally brings us to our star player. Deep learning. This is a special, superpowered type of machine learning, and its secret weapon? It uses a structure that's actually inspired by the human brain, something called an artificial neural network. Okay, so this whole brain-like learning thing, how does that even begin? Well, believe it or not, it all boils down to one single tiny building block. We're going to build one artificial neuron right now, from scratch. And to make this feel real, let's use a fantastic and kind of delicious example. Just imagine there's a big cheese festival happening this weekend. The simple question is, are you going or are you staying home? So when you're making a choice like that, your brain just naturally weighs a few different things, right? Let's say for this decision, there are three main factors. 1, is the weather going to be nice? 2, does your partner want to go with you? And 3, is it easy to get there? 3 simple yes or no questions. Okay, and here it is. This is the absolute key. An artificial neuron, technically called a perceptron, does this exact same thing, but it uses numbers. It assigns a weight to each one of those factors. You can just think of it as an importance score. It's how the neuron knows what you really care about. For example, let's say you absolutely despise bad weather. Rain is a total deal breaker. In that case, you give the good weather factor a really high weight, a big importance score. Let's call it a 6. That tells the system, hey, this one matters a lot. Now, what about the other two things? You'd like your partner to come, and easy transit is for sure a plus, but neither of them is a deal breaker like the weather. So we'll give both of those a much lower weight, something like a 2. So here's how it all comes together. The neuron has a decision threshold. Let's say you need a total score of 5 to convince you to go. Now, just do the math. If the weather is good, boom, you get 6 points right away. You're already over the threshold of 5, so you're going, even if your partner says no and the transit is a mess. But if the weather is bad, you get 0 points for that factor, and there's no way to reach 5 with just the other 2. You stay home. See? It's just a simple mathematical decision maker. Now, that one little neuron is, well, it's pretty basic, right? It can only make one simple choice. But here is where things get truly mind-blowing. What happens when you connect not one, but thousands or even millions of these little guys together into a massive system? Well, you get an artificial neural network. It's basically a giant team of these simple decision makers all working together. The answers from one layer of neurons get passed on as the questions for the next layer. And by collaborating like this, they can start to solve problems that are way, way more complex. And when you stack many of these layers on top of each other, that's when you can officially call it a deep neural network. That is the deep in deep learning. And that depth is the whole magic trick. The first layer might learn to see simple things, like edges and corners in a photo. The next layer puts those together to see shapes. The layer after that might recognize an eye or a nose. And eventually, a layer deep inside can confidently say, hey, that's a cat's face. Okay, we've built the structure. We have this big layered network of neurons, but right now it's just a jumble of random weights. It doesn't actually know anything. So the billion-dollar question is, how does it actually learn anything? Well, it's a simple two-step dance. Step one is called forward propagation. All that means is you give it some data, let's say a picture of a dog. The information flows forward through all the layers. Each neuron does its little calculation, and at the very end, the network spits out its first guess. It'll be something random, like, I think that's a car? Yeah, its first guess is going to be terrible. And that brings us to step two, which is the really clever part, back propagation. The network compares its dumb guess, car, to the right answer, dog. It calculates exactly how wrong it was. Then, and this is the amazing part, it sends that error message backwards through the entire network, telling every single neuron how much it contributed to the mistake. Then, each neuron adjusts its weights just a tiny, tiny bit to be a little less wrong next time. It's just a constant loop of guessing and correcting millions of times over. Now, this correction process isn't just random. It's guided by two really important mathematical tools. The first is a loss function. You could think of this like the teacher's red pen that grades the test and gives a score for exactly how wrong the answer was. Then you have an optimizer. This acts like a guide that tells the network the most efficient way to adjust all those weights to get a better score on the next try. This whole process we've been describing, showing a network a bunch of examples with the right answers and letting it learn to make its own predictions, that has a name. It's called supervised learning. And honestly, it is by far the most successful, most impactful reason that AI is suddenly everywhere in our lives. I mean, just look at how widespread it is. Every time you see a photo automatically tagged on social media, that's a network that learned to map an image, the input, to a person's name, the output. When you talk to your phone and it magically turns into text, that's a network mapping an audio clip to a transcript. Online ads, language translation, even key parts of self-driving cars, it's all the same idea of learning from labeled examples. So if you take away just one thing from this whole explainer, let it be this. Almost all of the AI breakthroughs, all of the economic value, all of the things that make you go wow in the last decade have come from this one single idea. Supervised learning with deep neural networks. It's the engine that's been driving this whole revolution. So there you have it. We've gone all the way from one simple decision about a cheese festival to a vast, complex network that can actually learn. But really, we've only scratched the surface. This quote from one of the pioneers of the field, Yann LeCun, it kind of shows you that even the experts are still debating the best ways to get these things to learn better. We've built the engine, but the biggest question still remains. Now that we know how to make machines learn from our data, what should we teach them to do next?